All right, let's take a look at our lesson for today. So you probably haven't heard this word in a little while, proofs. And I don't know what kind of thinking it brings back to you. I can tell you I adore trig proofs. And I mean, y'all already know I'm a little strange, so it probably isn't saying anything. We're going to be working on trig proofs for a couple of class periods. This is the first period. We're going to, kind of jump in there. And then we'll do it one more class period. So what I would like to do before I jump into the proofs is I would like to refer back to a lesson that we did in the first chapter of the textbook that we're covering, chapter 6. Let's just kind of, if you want to go back to your notes back then, you want to take a look. Let's talk about these particular, what we call these. So the reciprocal, let me just highlight right here. So these are reciprocal identities, okay? When we do proofs, we're going to be naming the rule that we're using or the identity property that we're using. And so for these 6 right here, these are reciprocal identities. Then we have quotient identities. And so let me back up just for a moment. So what we would do on a proof is we would abbreviate this as RECIP. Just abbreviations. That's enough for me to know. RECIP is just short for reciprocal. For the quotient IDs that are listed, they're right down here. These are the quotient identities. We would just abbreviate it as QUOT. That's good enough that I know that you're talking about a quotient identity. Pythagorean identities, these guys right here, we'll be using those. We abbreviate that as PYTHAG, just shortened. We have even odd identities that we're going to be using, and so we would just abbreviate it as even odd. There's one more type of identities that we're going to use in this section of the book, and those are called co-function identities. So we're going to add this to our list. It's called co-function identities, and that IDs is just abbreviation for identities. And so the co-function identities are, we're just going to look at 2 of them. It's cosine of pi over 2 minus theta is the same as sine of theta. And sine of pi over 2 minus theta is the same as cosine theta. Okay, so these are new. And let's just highlight them. They're called co-function identities. And we would just abbreviate as COFUNCT, so something like that, co-function. Okay, so these, it's going to be important to us that we started on our memory work for these from the last unit. It's going to be important that we have these in our brain, because if we don't, it's going to make our proof work extraordinarily difficult. If you don't know what you're looking for or what you can use, it's going to be really hard to do a proof. Okay, so this is our foundation. These are our foundational identities that we kind of need to have under our belt. We really need to know these identities. All right, and this is back on our lesson from 6.3. Any questions about that? Okay. So you can take a picture of this slide if you want to from way back when and pull it into, that's actually what I did. There's my slide. I just took a picture of it and I put it right next to it so I could write on it and add the co-function identities. Whatever is most comfortable for you, you need to be able to reference those, access those. All right, so let's jump into what our project is for today. And we're basically going to be utilizing trig identities. So let's kind of go through some steps. So if we want to prove a trig identity, let's take a look at some steps that we would use to prove. Okay, the first thing, and this is just a guideline to choose the more complicated side to simplify. This is a guideline. You don't have to do that. But many times when you choose the more complicated side to simplify, it makes your life a little easier. But I need to put a big like asterisk out here. This is really important. You can only work on one side of the proof. Period. Only. And I tell students this. I've told my students this for many, many, many years. And 95% of them follow it and understand it. And there's about 5% that just try to work both sides at the same time. You cannot do that. That is not this type of proof. It's not a transitive proof. This is just a proof where what we want to do is we want to take one side and turn it into the other. So this is really important. Just pick one side and leave the other side alone. Don't touch it. Now, what kinds of things are we going to do? There's several different kinds of things that we can do. We can look for some algebra things to do. We could try to, fractions, greatest common factor. We could multiply by a clever form of 1, like the conjugate. We could add, get a common denominator, add stuff together. We could do obvious algebra stuff like distributing, squaring, multiplying. I mean, there's lots of algebra stuff that we can do, that we can look forward to doing. Another thing that we should look for is trig. We want to look for trig things to do. We have these formulas under our belt. We want to be able to use them. Look for things like 1 minus cosine squared. When you see that, your brain should say, oh, that's the same thing as sine squared. Cosine times secant. Maybe you could use a reciprocal property and turn that into something. Sine over cosine, that's a quotient property. So you need to think of some trig things to do. If you see squares, then it's probably a good idea to think of the Pythagorean properties. Those are linked to the squaring of the functions. And then we want to shrink them. We want to reduce the number of different functions. And here's our end result. So I circled at the beginning, only work one side. So I'll circle that again, only work one side. Our ending is we want to keep looking at the answer to make sure we're headed in the right direction. Okay, this is our beginning and ending statement. So work on one side and keep looking at the answer. Keep looking to see that we're going in the same direction that we want to go in. All right, I want to pause here for a second. That's a lot of things to talk about, and we're going to see it as we work through these problems. Are there any questions for me before we keep going? Now, I want you to really understand that there's more than one way to get to the answer. And I'll show you how that works in one of the problems that we're doing. There's more than one way, and that's okay. Okay? Our textbook is going to ask you certain questions to lead you a certain way down the path. But we're also going to do some proofs that are just on OneNote, just by hand, so we can get a feel for working them by hand as well, not just on the textbook. Because of course, you're going to have to do them by hand on the test. So we're going to work both kinds, okay? All right, so let's go to the next page. We're going to do a couple of simplification things. So this is another concept that we need to be aware of. Simplifying. I wrote it down here, what our guideline is. Sometimes I think simplifying is harder than proofs because we don't really know where we're going. What is our goal? Our goal is to shrink the expression. We want to make it as small as possible. How do we do that? Okay, we want to try to get it to one fraction. That would be one thing that we could do. And we want to try to get it to one trig function. That would be a second thing that we could do. So those are kind of our overall goals. Their overall goals on simplifying is that we want to shrink it and we want to just have one trig function. Now that's not always possible, but that's certainly our overall goal. So with that in mind, let's work the first two problems. The first two are just simplification problems where we're trying to shrink things and get them into one type of trig function instead of a bunch. So as we look at that first one, this right here is something I just talked to you about. This is new for us. This is a cofunction property. Do we remember from the little properties that I just showed you, what is cosine of pi over 2 minus theta equal to? Sine theta. So what we're going to do is we're going to replace the numerator with sine theta. We're going to put the denominator there, and by the side we're going to write cofunction. That's the reason we did what we did. You really need to give me the reason that you're doing what you're doing for a lot of different reasons. That really helps solidify the step in your mind, and it also helps me follow your work. All right, so this is great news. We've gotten, we're making some progress. We took that big thing on the numerator, we made it smaller. Now let's see if we can work with what we have. Sine is pretty straightforward. Cosecant, though, let's see, cosecant is the reciprocal of what?
1 over sine.
It's 1 over sine. So why don't we go into this? This is my main fraction bar. Why don't we change cosecant into 1 over sine? And this is called, we did the reciprocal, RECIP. We did reciprocal identity. Okay, great. We're making progress. Oh, good. We have just one trig function. We're happy about that. But we do have a complex fraction. Do you remember how to fix complex fractions? Keep, change, flip. Keep the top, change division to multiplication, flip the bottom. Let's do that. Let's keep, change, flip. So I keep the top. I do multiplication. I flip the bottom. So it would be sine over 1. And here I'm just going to say complex fraction because that's all I'm doing. I'm messing with a complex fraction. Okay, is there anything else that we can do to make that smaller? What can we do to make that smaller? Yeah, sine times sine is just sine squared. So let's do that. So sine times sine is sine squared. And here we just multiplied. And that's pretty much as small as we can get it. I mean, it's down to one trig function. I don't have any fractions. Great. We're pretty much done. That's simplified. Okay, I'm going to pause here for a moment. Are we okay with that? Okay, we're just kind of working as we're going. We're trying to figure out things as we're going. All right, so let's look at number 2. The numerator should kind of look familiar to you from our last lesson on solving trig equations. Do we remember what technique we used when we're solving trig equations when we had something that looked like that?
FOIL.
We factor like FOIL. That's exactly what we're going to do. We're going to factor like FOIL. So let's set those factors up. Let's see, so we've got 2 sine and sine. Let's see, we've got a 3 times 1 is 3, so let's try the 3 here and the 1 here. Let's see, our signs need to be opposite. I need to end up with a -1, so let's do here's negative and here's positive. And what did we do? We factored. I'm just going to write factored. Okay, is everybody comfortable with the factoring? So what has that opened up for us? We can now cancel, right? We can cancel. Did y'all see what we can cancel? Sine x plus 1. Very nice. We're going to cancel that. We're going to say 2 sine x minus 3. And our reason is cancel. And there's really nothing we can do from here. I mean, that's kind of it. I'm down to one trig function. I don't have a fraction. That's about as good as I can get. Does it make sense how I can't go any farther than that? One of the questions I typically get is, well, how do I know when to stop? Well, what you want to stop when you've got it shrunk really small and you're down to one trig function and you don't have a fraction. That would be when you could stop. Now, sometimes you can't get that far, but that's our goal. Our goal is get down to one trig function and get rid of the fractions, or at least only have one. All right, how are we with simplification? Is that okay? Okay, so now let's jump into proofs. When it says establish the identity, it just means just do this proof, is what it means. So I'm looking at number 3, I'm looking at the left side, I'm looking at the right side. I'm going to pick the side that looks the most difficult, which looks to me like the left side. Y'all okay with that? I'm going to pick the left side. I'm going to leave the right side alone. Okay, so let's think about that. I've got a cosecant, I've got a tangent. There are several things I can think of. I think I want to start with a reciprocal property on cosecant. Why not? I mean, we're not exactly sure where we're going, but as long as we don't make a mistake in our trig or our algebra, we will not go wrong. It just might take us longer. It's okay. So I'm going to change cosecant into 1 over sine. And then I have my tangent equals, and I'm going to use this sim RHS. RHS means right hand side. The reason I want to do this for 2 reasons. One reason is it's quicker to write than some more difficult things, right hand side. A second reason is I'm not allowed to touch that side anyway. I can't touch it anyway. So why do I want to bring it along with me and tempt myself to touch it? I can't touch it. In fact, where I'm going, I might as well just highlight this. This is where I want to be. I want to turn the left side into secant. That's what I want to do. I don't have any secants over there yet, but I'm working on it, right? I'm working on it. And my reason for going from cosecant to 1 over sine was reciprocal. Okay, is everybody okay so far? Now we just think of other things to do. I mean, it might not help us, but we might as well try. Well, tangent, that's a quotient property. I can do a quotient property for tangent, right? So I've got 1 over sine times, see, tangent is sine over cosine equals right hand side, and I just did quotient property. Okay, good, making progress. Now we want to end up to be secant. This is true, and I can't work that secant side, but what is another way to write secant? 1 over cosine. Do we see something like that forming up on the left, a 1 over cosine? We do, don't we? And so we see that we're getting close to the answer. So at this point, I simply want to cancel, and I have 1 over sine equals RHS, and my reason is cancel. Oh, cosine, thank you. 1 over cosine, and I canceled. And now what should I do?
Right, the right hand side equals secant.
So secant, and how did I get to secant? What is my reason for turning into secant? And I'm going to go ahead and write secant as secant, because that's fine.
Reciprocal.
Reciprocal, very nice. That was our very first full proof. How are we doing? Is that okay? This is a 4-step proof. Well, we did 4 steps. So I don't want us to get really focused on how many steps we're doing, because I may see it in 7 steps and you may see it in 4, and they could both very well be correct. We just went about it a different way. So when you're working on your homework, I really would like for you to write these proofs out on like a OneNote page, like open up a scratch page and write all your work out so you can kind of focus on what you're doing, since that's the way you're going to be tested, is by writing it all out. Okay? Now let's take a look at number 4. So I'm going to follow the conventional wisdom and I'm going to work on the left-hand side. I will tell you that I did it working on the right-hand side and got there much faster, and I'll show you that after I do the left-hand side, because what our normal path would be is to work on the hardest side. That's what we would normally do. So that's what, let's do that. We're just going to work on the normal side. In order to get rid of the fraction, one thing that I can try is to multiply by the conjugate of the denominator over itself, a clever form of 1. So that's what I'm going to do. I'm going to copy down the numerator and the denominator. I'm going to multiply that by 1 minus cotangent x over 1 minus cotangent x equals right-hand side RHS, and you can say multiply by 1 or a clever form of 1, whichever you want to. Okay, that's a clever form of 1. So I'm going to just multiply everything out because so what's our goal? Our goal is to be here. I need to somehow shrink all of that big mess to just a tangent. So I should not have any parentheses left, right, in the end. I'm just going to have a tangent. So let's FOIL all that out. I hope we remember that that would be foiling. So 1 times 1 is 1. 1 times negative cotangent is negative cotangent. Tangent times 1 is tangent. And then minus tangent cotangent. That's in my numerator. Equals right-hand side. My denominator, they're conjugates of each other, so it's going to just turn out to be 1 minus cotangent squared. And this is just, the reason is multiply. Okay. So I've got a squared. I want to kind of investigate my Pythagorean identities. When I'm working some proofs, I just write this up at the top. Sine squared plus cosine squared is 1. And I write the other two. I would divide everything by sine squared, and that gives me 1 plus cotangent squared equals cosecant squared. Divide everything by cosine squared, and I get tangent squared plus 1 equals secant squared. Okay. So I have a cotangent squared down there, but my formula is 1 plus cotangent squared, not 1 minus cotangent squared. So that seems like a big problem. I don't really want to use one of the Pythagorean identities because I want to get to tangent. And I've got a couple tangents up there already. And cotangent, can I turn cotangent into tangent? Yeah. I can, can't I? So I think I'm just going to try to make everything tangent and see what happens. That's what I'm going to do, because that's where I'm going. I'm focusing on where I'm going. Okay, I need to be tangent, and I've got some tangents, but they're not all tangents. So let's just work on turning all the cotangents into tangents. So that's using the reciprocal property. So it's going to be 1 minus 1 over tangent plus tangent minus tangent times 1 over tangent all over 1 minus 1 over tangent squared equals right-hand side, and I did reciprocal. Okay. Now I want you to focus on this little piece for a moment. What is tangent over tangent? It's 1. It cancels to 1. And I have 1, basically 1 minus 1. This turns into a 1. So those are going to go away. Y'all with me? You see how the 1 minus 1 is going to be gone? And so let's just rewrite it. after that step. So I have negative 1 over tangent plus tangent over 1 minus 1 over tangent squared equals right-hand side. And I just, I canceled and I added. You're allowed to do 2 steps in one line. You're not allowed to do more than 2 steps. Otherwise, it's way too hard to follow. Okay, so I did 2 things. I canceled tangent over tangent is 1, and then I did 1 minus 1 is 0. All right, very good. Now I've got a complex fraction. What would you think if you had a complex fraction? What should we try? We should try to add the numerator together, add the denominator together, fix our complex fraction, right? We're going to go through that process that we've done so many times, and it's not our favorite thing to do, but it really is something we've got to have in our brain. So what I'm going to do is I'm going to get common denominator. I'm going to multiply this by tangent x over tangent x. So I can add those 2 things on the top together. And I'll multiply this by tangent squared x over tangent squared x. Okay. So we're going to have to move up here. All right, so I wrote out my work. Now I'm going to do it. So I have negative 1 over tangent x plus tangent squared x over tangent over tangent squared x over tangent squared x minus 1 over tangent squared x equals right-hand side. And here I am doing, I could say multiply by 1, or I could say common denominator. I'm going to say common denominator because that seems to make more sense to what I'm doing. Now I'm going to add them together. So at the top, you see I have negative 1 plus tangent squared. I'm just going to rewrite it to tangent squared minus 1 just because that's what I want to do. You don't have to. All right, so I combine those 2 fractions together because now I have a common denominator. I'm just going to say add, add fractions. Okay, so I've got tangent squared minus 1 over tangent all over tangent squared minus 1 over tangent squared. Okay, what should we do now? We've got a big old complex fraction. We're ready to keep, change, flip, right? We're ready to do that. Keep the top. Change division to multiplication. Flip the bottom. And I'm just going to write complex fraction. Does anyone see something that we can do?
Cancel.
We can cancel, right? I got tangent squared minus 1 over tangent squared minus 1. What is that going to equal? 1. That's going to go away. So we're going to have tangent squared over tangent equals right-hand side. And I'm going to say cancel. We are so close to home. We are continually looking at our goal. Our goal is to be tangent. Are we ready to be tangent? Tangent squared over tangent. It does. So if this was bothering us and we wanted to write it out, tangent squared means tangent, tangent. over tangent. That's what it means, right? Tangent squared means there's two tangents. And I'm just going to say expand. And so here we can see that those go away. And I'm left with tangent x equals tangent x. And this is cancel. Okay, so I did 1, 2, 3, 4, 5, 6, 7, 8, 9. This proof was 10 steps. And we got where we're going. Okay, I'm going to give you just a moment to get that all copied down. Are there any questions on any part of that proof? Now, I want to show you this same proof that I did by working on the right side instead of the left side. Just so that you can see, you're still going to get to the same place, just depending on, what you do. So let me pull this over and show you. This way I did it, there were 4 steps instead of 10. And what I did is I left the more complicated side alone, and I multiplied by a clever form of 1, because I knew I needed 1 plus cotangent on the bottom. I knew I needed that. So I decided to multiply by 1 plus cotangent over 1 plus cotangent. So yay, I got the denominator is set. I don't need to mess with it at all. Then it's a matter of working on the numerator to turn it into 1 plus tangent. And after I distribute and do some reciprocal work, I'm there. Now, that's unusual. Normally, if you try to work on the easier side, normally it's harder. But in this case, it was actually easier. Does that make sense? So it's okay if you go down one path and you want to start over. That's okay. There are a variety of ways to get to the same place. Okay? Right.